Hi, this is Alex.
And welcome back.
In today's episode, we have a special guest. Do you want to introduce yourself?
Hi, I'm Costanza.
Hi, welcome to our podcast.
So guys, as per our last episode, I have indeed definitely jinxed the weather.
Yeah, no more snow, definitely.
Just a lot of rain, a lot of wind, and very, very bad weather.
And very cold.
Yeah, it's my fault.
Yeah.
Thank you so much.
You're welcome.
Thank you for your contribution.
Right now.
Thank you for your contribution for the jinxing of the weather.
I mean, someone had to.
Oh, come on. You're in Scotland. Weather change 4 times a day.
Exactly. We can literally see sunrise and sunset within 3 hours now.
Yeah, that's just really, really upsetting, especially because, my friends back home, they're just like, oh, yeah, it was a nice 17-degree day today. I didn't have much to do, so I went to the beach. I'm here like, oh, thank you. You know what I did today? I looked at the rain and thought about my future. Both of those things, very dark. Very dark.
Do you want to tell our viewers where you come from?
Well, I'm originally from Italy, but my parents are diplomats, so we kind of lived around the world. I spent most of my time in the States, hence the American accent you can hear right now.
Yeehaw.
Oh my God. No. Not yeehaw.
So do you want to tell us about your project?
Yes, it is why I'm here. Basically, I work with zebrafish and trying to identify pigmentation genes. And basically the way my project started is someone called Ian Jackson and a lot of other people did this big genetic analysis using the UK Biobank. And they identified some genes which have to do with blonde hair and red hair, which are markers of pigmentation selection. And basically, if you have blonde hair or red hair, a mutation happened along the way, making your hair a different color than what is evolutionarily better. And what makes your skin lighter, which makes you more prone to melanoma and also some other types of cancers, but especially melanoma because you don't have that protection against UV light. And just studying pigmentation through the use of hair colors is really useful because you can see the actual effect that your genes and the changes in your genes have on how you look. And these studies have been conducted for a very long time, I think, since the 90s. And now there's about 200 pigmentation genes that have been identified. Some are more important than others. And what I'm studying right now is a gene called MC1R, which if you have it, you're very, very, very likely to have red hair, and SLC12A9, which is a gene that has not been confirmed to be a pigmentation gene, but we're studying it and comparing it to MC1R to see if it is a pigmentation gene and if it does have an effect and could possibly tell us more about the evolution of skin type, of pigmentation, and not really mankind. We're not there yet, but, baby steps.
Interesting.
Thank you.
How do you study that?
Basically, zebrafish are a very, very useful model organism to do that because you can see right away what the change is. They're not obstructed by fur like mice would be.
So they're transparent?
Somewhat. What's really interesting about them is that when they're 5 days old, so when they finish the embryo stage of their life, they develop their pigment cells called melanophores. What usually happens is if a pigmentation gene is compromised in some way, those melanophores will act differently under light, and the zebrafish won't be able to camouflage itself very well under light because their melanophores normally react to light. And so if there's a lot of light, they constrict, meaning they get smaller. And so you don't see the dark pigment very well. And that helps them with predators. But if it's dark, then they expand, meaning that also the melanophores become bigger. They just are more compact and they're more together. And again, that helps them also with predators.
Except humans?
Well, yeah.
Well, they end up in a tank.
Yeah. Or under a microscope.
Well,
that's true. Sorry, we're not making fun of your project.
No, I mean, obviously, they're just I'm not really sure how to respond to that. Like, does it help them with humans? We're in an enclosed space. I have a net. I'm better than them. I can just whip them out.
Yeah. That's evolution. Survival of the fittest.
Yeah, exactly.
Yeah.
In a zebrafish case.
Yeah.
Yeah.
Or if we try hard enough, we will also develop gills and breathe underwater. So we will become the alpha evolution people things.
Why do you want to be underwater?
So I can live out my dream of being Ariel from The Little Mermaid.
Don't sing. Please don't sing.
No, I won't.
You sort of already have the hair.
My hair's not red.
Yeah, but it's curl.
Ariel did not have curly hair.
Really?
No.
So if anything, you're just describing traits on Costanza that are further away from
Yeah.
than anything.
I have very dark blonde bordering on brunette hair.
I don't know why does she have curly hair. Maybe her hair looked like plumped up.
It's because of all that sea salt.
It's because she's underwater and it flows majestically.
Probably. Is that why you want to breathe underwater?
So it flows
So
majestically.
technically you want to be a mermaid.
Well, yeah, also because I feel like if I were a mermaid, most of my issues would be solved.
What do you
so?
mean?
Honestly,
Chasing zebra fishes?
no.
You'd study them in their natural habitat.
Yeah, no, I
Please,
could.
101.
I could experiment on myself. Like, look at how the melanophores on my fins change because of light. I'm gonna escape you, Ursula, or what? I don't know. Ursula was the evil witch.
Yeah.
that
Yeah,
I think
was
she
also
was,
an
yeah.
octopus or something.
I mean,
Not a
to be
mermaid.
fair, she got a good deal out of it. She lost her tongue, but she gained legs. Like,
Yeah. True.
yeah, I mean, if anything, Ursula was fair, and she just didn't want to, she wanted everything.
Yeah. Honestly, I'd be very, very happy to get the deal that Ariel had and like not ever be able to speak at all. But then I'd prefer it if other people around me also weren't able to speak. If everybody was mute, I think it would be
Yeah, but who would sing songs?
nobody.
Exactly.
We would just hear instruments like when...
But you can't tell how... I don't know.
If you're mute, you can hear Farah. If you can hear...
For once, the sass isn't coming from me.
You've known me long enough to know that I'm very, very sassy.
I know, but it's just in my head, like mute means you can't hear. I know you can't speak, but I thought like you comes both can't hear and can't speak.
No, that's cool. No.
That's a deaf mute
Yeah.
person. If you're deaf, you can't hear. They're not mutually exclusive. They're separate.
It's like you can get both, like deaf and
Well,
mute.
because
But you can
they-
have like deaf, or you can have mute, but you can't have both.
You
Wait, why can't you have
be
both?
You can.
Oh,
be-
okay.
Yeah.
But because both of them use sign languages, so I'm confused.
Well,
What?
Well, yeah, you use
Yeah.
sign language if you're deaf because you can feel the vibrations in your throat, but you can't actually kind of tell exactly
But mute
what you
people
say.
use sign
Sign
language as well, so this
they
confuses me.
because they can't speak. It's a form of communication, but like
So like, if you can't hear, you're gonna use sign language because you can see. If you
Yeah.
can't speak, you're not gonna.
Yeah, but
see
if a two
sign language because
person
you
use
can see.
sign language, if I just sit here and watch them, I can't tell if they're mute or like deaf. So I'm saying.
well, you can ask them. I don't think it's inappropriate to ask.
But if they can't hear, then what's the point of asking?
No,
One-
no, you would ask in sign language, obviously.
Yeah.
All right.
Or the majority of both mute, like if you're mute, you obviously can hear, but the majority of deaf people can also lip read.
They can breathe.
Lip read.
Yeah. I'm pretty sure they can breathe. I'm pretty sure we're all breathing right now.
Well, if you're underwater,
Well, you still technically sort of somewhat breathe.
well, you're passing water through your gills.
Yeah,
so,
through my
yeah.
gills. That's how
Oh,
it would
someone
work.
told me that. Is it true? You should try this in your lab. Like, if you pull the fish the opposite way, you can drown them.
No.
What?
Yeah.
That is sadist.
Well,
Someone told me that.
didn't you guys have a podcast on ethics and things? Wouldn't that be unethical?
Yeah.
That's the complete opposite of what you
Yeah,
do.
I didn't say it's
ju-
ethical. I'm just telling a story.
Well, so what am I gonna do? Oh, guys, I'm bored. Let me just
Drag
make
the
my
fish
fish
backward.
moonwalk so that maybe I can kill him. That's gonna be a spicy Wednesday night for me. I said spicy instead of spicy, and I hate myself so much for it.
It's like that basic accent, like spicy.
Spicy. It's the American basic. coming out.
Yes, bringing it out. So, talking about your research. So the paper that you're going to talk about, tell us more about it.
I mean, if I'm not wrong, the paper I gave you is just kind of a comprehensive review, and they basically just put all the information that they already have on the major pigmentation genes that are known, and they compare them between zebrafish and mice and humans. Right?
Yeah.
Okay. Sorry, I just wrote my report.
It is your paper. So.
Yeah, I know, but I honestly have, I think it's 17 papers on just pigmentation genes alone. And I just really don't know which one I'm talking about right now. I think I gave you the review, didn't I?
Yeah, so the review is a good paper. It gives you the review of the whole field.
Yeah. Well, basically, the basic information is there, and I think it was a good paper to have, and it's important because it kind of shows the similarities between the different species and how relevant some genes are between one species and another. And honestly, it's just interesting to see how many similarities we have, even though we're very, very different.
What is your opinion on comparing the similarity of genes in human and in animal?
So between...
Would you say it's a good model?
Well, yeah, I think so, because especially zebrafish, because in 3 months, they go from being embryos to being adults who can mate, who can reproduce. And so that's really useful scientifically, because you do all of this in less amount of time. And especially more often than not now, things are being CRISPR mutated. And so you can mutate the embryo when it's a couple hours old, and you can have a good model. And in around 9 months' time, you can reach a second generation, and you can have good models to actually conduct your experiments in. And in mice, I think it takes about double the time. I think it takes around a year to a year and a half to do that. But mice are a little bit better in some scenarios than fish are. But I just think using those model organisms when compared to humans is really, really useful. And it's important to actually understand the pathways that, not just pigmentation, but all biological pathways, what they go through, how certain things happen. And it's just good to study them in models that don't take as long.
Do you want to explain to our viewers what CRISPR is?
Yes, it's a form of gene editing. So basically what you do is you find a piece of DNA that you're interested in, and you want to see what would happen if you mutate that DNA. And that could be by taking out one base pair or more than that, and actually seeing the effect that it has on the gene itself, on the organism, on if the organism survives, on protein production, on just everything that happens in the long run. And this can be done, has been done for modeling diseases, which has been really, really useful in general. And even to model, I think, what my lab is focused on is melanoma and cancer in general. So it's just really useful because you can by mutating that one gene and by using CRISPR, which is so advanced right now. And I think it was my supervisor was telling me that 10 years ago, if you had a 2% success rate, you were very, very happy, and it was so great, and everybody
life is amazing. Good day in lab.
And now, a lot of times, if you're good at injections, if the embryos take up the CRISPR construct that you put in them really well, you could have a 90% success rate, which is amazing. And just in the short amount of time that things have advanced so far, and it's such a good way to actually see the progress of how certain diseases work, on how pathways work, on how things translate from your DNA, from the genotype to the phenotype. And you can see all of this in a short span of time. And CRISPR is relatively good at doing this because as we get better with the technology, there's less developmental defects that the model organisms develop as they grow up. And so you can actually have a healthy model with the gene interruption that you want it. And it's just a good model. It's just a good thing to use to actually understand.
So it's almost like cut and paste, where you cut a certain bit of your DNA and paste it someone foreign.
Yeah, basically, yeah. I think it's more just cut.
Yeah,
rather than the base thing. But yeah, it's basically that.
And copy.
It's, not necessarily copy, because when you usually inject embryos, at least zebrafish embryos, are at the one cell stage. So it's just. Oh well, no, yeah, they do technically cut
Because
they
you need to
expand.
multiply.
Yeah, but the CRISPR construct itself, I think. Well, I'm not going to say too much about it, just because I'm still reading a lot of things that have to do with it. But there's many ways to CRISPR mutate something. You can either create something with a DNA vector, or you can directly inject the RNA into the embryo, which I think is what my lab has done. Because if you do it at the one cell stage, you inject it directly into the embryo, then it's fine. And you can also inject constructs in the yolk. You can inject things into the embryo at any stage you want. So even at 5 days old. Oopsie.
For viewers, this is Costanza just banging her chair in the table.
It wasn't my
She's a bit
chair.
nervous.
No, well, I fidget
Yes.
because
Stop that.
I do, and that was fair opening her water bottle. I'm not the only mess.
Well, to be fair, I did confiscate your coffee
Lucky.
cup.
Yeah, my coffee, and I'm looking at it from far away.
Yes, because you were fidgeting and I could clearly see it on the recording.
Well, that's upsetting for
Yes.
me, because I don't have my caffeine,
Well,
and I
it's
needed this.
Yeah, well, it's upsetting for me because I had to do so.
Everything's upsetting for you.
No,
No.
no,
No.
no.
Yeah.
It's more towards life than upsetting about something. Like coffee.
Oh no, that is upsetting.
That's because I'm not a coffee or caffeine addict.
But you can have coffee at your desk.
Yeah, but I
We
don't.
cannot. Well, you can. I
I can.
cannot.
Why can you?
Because our office area is separate from our lab area, so we don't have our computers and things in the lab itself. I ate 3 cookies today while I was trying to
Just
analyze
3.
Well, I ate 3 cookies and coffee at like 11 while I was trying to analyze some DNA sequences and see if the CRISPR thing worked. So hey, it did.
How would you describe your daily life in the labs? Like, so to jump from one subject to the other, but like,
Yeah, no, it's I mean, get there in the morning.
Like what
well,
time?
like, well, not a general feeling. Like say, like,
I walk in with motivation.
yeah, no, but like, so how would you describe your point of view of a student in your lab with your supervisor and, everything?
I mean, I think Liz is a great supervisor. She's helped me countless times when I've been close to a mental breakdown, so that's been nice. And everyone else in the lab, like both postdocs and PhD students, have also been really, really helpful. Anytime I had a question or I couldn't find my direct supervisor, they stepped in, they helped me out. They've been teaching me a lot of things, and I think it's a good lab itself. Like, it's a good small little community, and I think that's a really, really good thing to have, because this has been the best lab I have been in so far, and
That's good for you.
yeah, I know, it really is.
Lucky.
And I've gone to internships before, and then there was my dissertation project as well. And the environment was really, really different, especially I can think of one specific internship where the PIs were not organized. Nothing was happening the way it should be. Anytime I somewhat asked a question, I was made to feel stupid, which is
that's a shame.
I know, it's horrible. And I like to ask a lot of questions because I think it's better for me to ask everything I can think to ask and be sure about what I'm doing.
It's better to ask a question before the experiment than
Yeah.
go and do it
And
and come back
instead-
later
yeah,
and
and
it's
then-
not working and you're like, well, I had a question, but I thought I'd ask you afterwards. And
Yeah.
like, oh, you should have asked before.
Well, it's a bit
And
too
then-
late, is it?
Yeah.
Yeah, exactly. And then you mess up something, and then like you're just there like, ooh, well, this isn't how it was supposed to happen. And it's just better to ask everything and just to have like a good relationship with the people in your lab. And I think just the fact that like they are helpful, they are willing to actually take the time, sit down with me and help me understand things. It's
That's really good.
Yeah, it's really wonderful, especially because, I mean, pigmentation in general, the only thing I knew about it before going there is that one lecture I had in first year of my undergrad, and then nothing else. And
That's it. Back at the back of your memory.
yeah, exactly. And just the fact that most of them, like even Liz, the PI herself, who is extremely busy, took the time to actually sit me down and make me understand and help me understand what I was doing, why I was doing it, was extremely, extremely helpful, which kind of differed from the experience that I had in my internship and in the first half of my undergrad, because I was just given papers and told, here you go, have fun with that. And I did not have fun with that. I had no fun at all. And I struggled to understand the material because obviously it was new. Everything was just thrown at me.
Right. So if you have to put a word for your lab, like a future students who wants to do their project, like PhD or master's or internship, what would you say to them?
To go ahead, to actually try hard to get into that lab, because it's a good environment and Liz will push you to do your best. And she does expect a lot out of the people working under her, but I think it's valid. I think, at least personally, I do want to do the best job I can do. And I don't mind the pressure that I get, just because it's not the type of pressure that tells you, if you don't do this right and if you don't do exactly what I say and give me good results, I will shun you, your family will be put to shame, and nobody will ever love you. It's more
okay, that's a bit traumatic.
Yeah, well, that was my internship, the really bad one that I was talking about. Yeah, and it was ridiculous because it was a subject that was completely different from anything I was used
that's
to.
the point of internship, for you to learn things, not to be perfect.
And they expected me to know everything right at the beginning, and I was just kind of
Did they know that you're an undergraduate?
Yeah, it was like a summer internship. It was like, hi, yes, never heard about any of this before.
Welcome.
Welcome. Yeah, and instead, with this lab, it's like Liz expects you to put in the work, but it's valid because there is pressure, but it's not the type of pressure that's bad. It's good pressure.
It's good for your own development as a scientist.
And it's more like, I believe you can do this and you know what you can and can't do. If you need anything, we're all here for you. And that's really good.
That's really
That's
sweet.
great.
Yeah.
Yeah, so thank you for coming, because we have to wrap this episode now. But thank you for participating. Thank you for sharing your experience. Also, thank you to all our listeners, all the people that share and react and
follow
us on social media. And we'll see you in the next episode.
See ya. Bye.
Bye.
Hey!